In our book, on page 146, in the Redox Chemistry chapter, we will be discussing oxidation numbers. Elements and compounds have oxidation numbers. These compounds are like H2O. Oxidation numbers represent the charges the elements and compounds would have if the electron in each bond belonged to the more electronegative element, which means the element that has more capacity of attracting electrons. We will now look at some rules for assigning oxidation numbers. The oxidation number of an uncombined element is 0. These are elements that are not part of compounds. The oxidation number of hydrogen is +1, and the oxidation number of oxygen is -2. As for other elements, we can work out the oxidation numbers in certain compounds. There are also rules for that. The main rule to remember is that the oxidation numbers in a compound must balance. For example, in NH3 there are 3 hydrogen atoms. Each of these hydrogen atoms has an oxidation number of +1. Some compounds have a total positive charge. Others have a total negative charge, but some, like NH3, are neutral, so their total charge is 0. So for NH3 to be neutral, knowing that we have 3 plus 1s, so we have +3 coming from 3 hydrogen atoms, N must have an oxidation number of -3, so as to balance the 3 hydrogen atoms in the compound NH3. -3 plus 1 plus 1 plus 1 equals 0, the -3 coming from the N and each +1 from the H. Let's try this again, this time with H2SO4. In H2SO4 we have 2 hydrogen atoms, each with +1, as we already know by now. We have 4 oxygen atoms, each with -2, and H2SO4 is neutral. So we know that the total charge has to be 0. Now we start with our calculations. We have 2 hydrogen atoms, that's +2, +1 for each. We have 4 oxygen atoms, that's -8, because -2 for each. And we know that the total has to be 0, so S must have an oxidation number of +6. And this is the more detailed calculation.